Thank you for joining this presentation. Today, we will be presenting you with an automated team of beach cleaning robots designed by
Ali Aljabar.
Jeanette Perez.
And Josue Oliveras Perez. So the problem is that our beaches are littered with aluminum cans and plastic bottles, and that poses an environmental problem and public health risks at the same time. Also, the current cleanup methods are just labor intensive, they're inconsistent, and they are not scalable. So our goal is to create a robotic system that automates that process and improves the cleanup overall of the beaches. The proposed solution is a robotic team that automates the beach cleaning process. So we have one robot called the Sandy Scout, we have another robot called the Lift Drone, and a third robot called Teradoc. So in this diagram, I am showing all the components of the Sandy Scout and some components that are internal that are not visible from the outside. So again, we have the ultrasonic sensor in the front, and this helps with proximity. We have the main rotor, and we have a micro servo motor inside that's moving the nozzle. So when it detects that there is an aluminum can or a plastic bottle, it moves the nozzle, the micro servo motor moves the nozzle, and then it sprays with the magnetic fluid. We can also see that there is a 9-volt battery inside of it, so it can power other components on the inside and outside of the Sandy Scout. We have a magnetic liquid reservoir, and that is where the liquid is being carried. We have a back rotor. We have another DC motor in the back. We have a network card so it can communicate with the lift drone and other Sandy Scouts. And we have another DC motor here that moves the main rotor. And then we have an Arduino Nano. So here's the Arduino microcontroller, and it's showing you all the pieces that make the Sandy Scout work.
Here is what the lift drone looks like, along with a labeled diagram of its separate parts. Off to the right, you'll see a flow chart. This flow chart basically describes how the lift drone turns on, then scans for magnetic tags, and takes flight to collect all trash if there are tags detected. Here we have the lift drone internal components. First, we have the Arduino board. We have the L293D switch, which you'll see the DC motors hooked up through this switch. The DC motors provide our flying component. Our ultrasonic distance sensor will detect things for flight management. Our micro servo will serve for our door and arm functionalities. And we also have a 9-volt battery for additional power source.
Here is what the pterodact looks like, along with the labeled diagram of its separate parts. And here we have a flow chart. As you can see, the pterodact serves as a power source for the team. It has a landing station for the lift drone to land and recharge, and to arm to unload the lift drone as well. It's made of 6 components. First, Arduino board. The second is ultrasonic distance sensor, and the LED bulbs, the micro servo, resistors, and lastly, the power button. As we can see on the picture, it's labeled.
This slide demonstrates the algorithm to complete the process of cleaning up the coastline. Starts with Sandy Scout, moves on to Lift Drone, and ends with Teradoc. The Sandy Scout starts by spraying magnetic tags on the waste detected around the coastline. The Lift Drone then ascends, collecting all the waste and returning back to complete its emptying and charging cycle.
In conclusion, the beach cleanup directly addresses the important needs in coastal cleanup, as its all-inclusive system provides substantial value, integrating specialized robots The process is streamlined from detection to removal and sorting, providing a more comprehensive and effective solution than what is currently offered. The following are the references used for this project. Thank you for watching.